this is a spec for the module on triangles, and it's pretty basic. It's a pretty basic module. It's really just to make the student familiar with the ideas of equilateral, isosceles, right triangles, congruent triangles, and similar triangles. So there'll be two types of problems here. The first type is we're just going to give a triangle. So it might be a triangle like that. A triangle like that. And we give some information about the triangle. So we might give the angles, but more likely we're going to give some of the side lengths. So let's say we say that this length is 6, this is 5, and that this length over here is 9 over here. And the choices will be, is this an equilateral, equilateral, equilateral? You have isosceles, isosceles, always have trouble spelling that. Isosceles, isosceles, isosceles. We'll throw scalene in there when all the lengths are different. It's a right triangle. And or we could even throw in, if we want, we can throw in some of the typical triangles that people see, 30, 60, 90, or 45, 45, 90. 45, 45, 90 triangle. And this will be a different type of choice mechanism than what we're used to. What we want the student to do is pick all that apply. So pick all that apply. So in this example, this would be a scalene triangle, and that's all. It wouldn't apply to any of the other ones. Now, if this was a if this was if this was if this length right here was 3, and this is a bit of a tricky question, this would have also been a right triangle. And the way that we would have proven it to the student when they click hint is to show that, look, 6 squared plus 3 squared is equal to 9 squared. So that means the Pythagorean theorem works. This is a right triangle. So that would probably be one of the trickiest problems. And it really allows them to recognize 3, 6, 9 right triangles, 3, 6, 9 right triangles. And then the other one that I think it's pretty good for students to recognize fairly quickly are the 3, 4, 5 right triangles. And so we could throw 45, 45, 90 here. We could throw 30, 60, 90. And so every now and then we can make the sides match up to a 45, 45, 90 or 30, 60, 90 triangle. Now the other type of problem, and you can obviously generate a lot of problems just with this, but the other type of problem we want to do is have them compare two triangles. Have them compare two triangles, and we give them some information. So let's say that we have something like this. And so there's a lot of drawings we can do here. We could do a drawing like this. And we assume that they would have already gone through the angle game and all of that. So we have, let's see, A, B, C, D, and E. And we could ask questions like compare, or well, actually, maybe the easiest one would be true false, because this would kind of foster the whole geometry proof aspect of it. So we would have a statement, and we could say triangle ABE is similar to triangle DEC. And when we and if this is all we have written, this would, in this case, well, it's going to just be true false. This is going to be a true false problem. If this is all we've written right here, actually it should be true false, not enough info, not enough info. The way I've written it right here, there's just not enough info. You know that this angle is congruent to that angle right there. They're opposite angles, or sometimes they're called vertical angles. But you know nothing else. Now, if I told you that AB is parallel to DC, if I were to draw that, and we could even draw it on the diagram for the students, then they do have enough information. Then they know from alternate interior angles that those two things are equal, and that they know that these two things are equal. So all three angles are equal. These are similar triangles. And we could do similar things with congruent triangles. And other shapes that we might want to draw here are things like, let me clear this out. Let me clear that out. So other shapes, I mean, you could literally just draw two separate triangles, but it's sometimes fun to make triangles inside of other triangles, force the student to visualize things. So you might have triangles that look like this. So you have a big triangle, and then you maybe have oh, I don't know, maybe a triangle inside of it or something like that. I'll let you be creative there. But the easiest thing to do is actually just draw two triangles every now and then. Is just to draw two triangles and have the students, based on the information available, figure out if they are congruent, similar, or there's not enough information. It could just be verifying whether a statement is true, false, or not giving enough information.